The synchronous queue is a special type of queue in Java that differs significantly from other queue implementations. It is designed to act as a synchronous handoff mechanism between two threads. This means that an element can only be inserted into the queue if another thread is ready to remove it, and vice versa. From the technical perspective, it extends the blocking queue interface, providing thread-safe operations for adding and removing elements. Unlike other queues, it has a capacity of 0. This means it can hold at most one element at a time. The put and take methods are blocking operations. Put will wait until a thread calls take, and vice versa. This ensures that elements are directly transferred from one thread to another, without intermediate storage. The peek and poll methods are not supported, as they wouldn't make any sense in the context of a synchronous handoff. You might ask why? I'm glad you asked, because this is a great question. The core concept of a synchronous queue is a direct synchronous handoff between two threads. This means that an element can only be inserted into the queue if another thread is ready to remove it, and vice versa. There's no intermediate storage or buffering. If the queue is empty, there's nothing to peek at. If there's an element, it's waiting for a thread to take it. There's no concept of looking at an element without removing it. If a thread could peek at a queue, it might unnecessarily block other threads waiting to put or take elements. So to sum up, the nature of a synchronous queue with its direct handoff mechanism and blocking operations makes the peek and poll methods redundant and potentially problematic. Alright, so what would common use cases for the synchronous queue be? The synchronous queue is ideal for passing data from one thread to another, eliminating the need for intermediate buffers or synchronization mechanisms, meaning that it is good for thread-to-thread communication. Also, it complies with the principles of the producer-consumer pattern, where a single producer thread produces elements and a single consumer thread consumes them, ensuring the direct handoff between the two. So why use the synchronous queue? Why not just use the array blocking queue and limit its capacity to 1? While it's technically possible to use an array blocking queue with a capacity of 1 to achieve a similar effect as a synchronous queue, there are several reasons why a synchronous queue is often more appropriate. Using a synchronous queue clearly conveys the intention of direct synchronous handoff between two threads. This improves the code readability and the maintainability. Also, the synchronous queue is specifically designed and optimized for this use case. It is likely to have a lower overhead compared to using an array blocking queue with a capacity of 1. The synchronous queue has a simpler API, as it doesn't provide methods like peek or poll, which aren't relevant in the context of synchronous handoffs. Alright, that's it with the basics. Now let's take a look at how to make use of the synchronous queue within a code example. By the way, I've uploaded the code of this video onto GitHub, so feel free to check it out and make a copy for yourself. Why not also show off your project skills and tell us in what way you implemented this type of queue in your project? Write a comment in the section below. Alright, so here we have a basic Maven project, and we also have 2 build scripts and 2 run scripts, depending on the operating system you're on. In case you use Windows, you're gonna use the build.cmd and the run.cmd, and in the case that you're on Mac or Linux, you use the build and the run script. Okay, so let's start by creating a synchronous queue of type string, which we name queue and in which we put a new instance of synchronous queue. Now let's create a new thread, which we call producer. And within the constructor of the thread, we place an anonymous method. The first thing we're going to do in here is print what we sent as a producer, which is hello. Now let's put this hello to the queue. As the synchronous queue has only a capacity of 1, by this point it is already full. Alright, the put method can also be interrupted, which can throw an exception. This is the reason why we have this red curly line underneath the put method. So let's build a try-catch context around it, in which we try to put hello, and if it fails, we can catch it in an interrupted exception. Alright, while we're at it, let's also print another message, producer world, and also put world in the queue. This will only work if between hello and world a consumer has consumed the hello, but we will see that in just an instance when we run the application. Alright, let's also output a text for the case that we get an interrupted exception, producer interrupted. Alright, that's it for the producer thread. Now let's build a consumer thread. So let's create a new thread, new variable consumer of type thread, in which we put a new instance of thread. The constructor again gets an anonymous method, in which we start by defining a string variable, message1, in which we put what we take from the queue. Just like the put method, the take method can also be interrupted. So let's put it into a try-catch context. Alright, now let's print the message that the consumer got. System out print line, consumer, and then the message. Let's do the same thing again. Let's define a new string variable, message2, in which we put what we take from the queue. Right after that, let's also output it, consumer and then message2. In the case that this gets interrupted, let's print the text consumer interrupted. Alright, that's it. The only thing that remains is starting both threads. So let's start the producer thread and the consumer thread. Okay, we're ready. So let's see this in action. Let's build and run the application. And here we can see the putting and the taking of hello and world. Now you might ask yourself, why isn't it first the producer hello and then the consumer hello and then the producer world and then the consumer world? Well, the reason is that the text that we are reading is a different operation than the putting and the taking of the queue. Because one time we're concentrated on print line and then we're concentrated on either put or take. And it just so happened that the printing of the producer hello and the producer world was faster than the consumer hello and the consumer world. Alright, let's prove that. So let's just not consume anything. Let's just run the producer without running the consumer. This way we should only end up having a producer hello, and that's it. Because the consumer hello will never happen, and therefore the producer world will not happen. So let's comment the consumer, and build and run the application again. And there we go, we only get the producer hello. As the application will be stuck here, waiting for the consumer hello, which will never happen, the only way to stop the application is to kill it by using Command and C. To sum up, in this video we first made sure we understood the basics of the synchronous queue. We then created a code example showing two threads being created. A producer thread was responsible for putting data into the queue, while a consumer thread was responsible for taking them out of the queue again. Alright, so did you like the format of this video? Give a like to this video, as it helps this channel grow on YouTube, and it also shows the level of appreciation for this type of content. You should also subscribe to this channel, as it is the best way to get informed about future videos just like this one. I would like to thank you very much for watching. My name is Gene. See you in the next video.